Review math number 6. Question number 1 says, the timers in the cafeteria are set to go off every 8, 10, and 12 minutes. They just sounded. When will they ring together at the same time? So I'm trying to figure out when that's going to happen again. So I look at the 8, 10, and 12, and I realize that I have to be finding a multiple of these numbers. So I start with 8, 10, and 12. And I count by 8. 8, 16, 24, 32, 10, 20, 30, 12, 24, 36. So I'm looking for when they're going to ring again at the same time for all three things. So I look here and I see that I've got a 24 and a 24, but I don't have a 24 in this list. So what that means is I have to continue my counting. So then I go to 40 and 40 and 48. Still nothing in common. So then 48, 50, 60, and I'm going to start up here, 56, and then the next one's 8 times 8, which is 64, 8 times 9, which is 72, 8 times 10, which is 80, and I know that this one will be 82, but will this one be 80? So 12, 24, so this will be next one will be 72, then 84, darn it, so I gotta keep going. So I've got 80, 88, 96, 104, and I can do these easily in my head, so I'm just going to skip those. This is the ones I'm looking at. So I've got 84, then I've got 96. Okay, 96, 96. Oh, darn it, that one doesn't work. So continue, so I got 104, then I'll have 112, then I'll have 120 for the 8s. This is still for my 8s. And down here I've got 96, then I've got 108, then I've got 120. Okay, so I've got 120 here, I've got 120 here. Is 120 a multiple of 10? Yes, yes it is. So that's what you need to figure out. Okay, next one. These next questions are all on graphing. And so I wrote the coordinate grid song over here. It says the coordinate grid, the x goes across and the y goes high. It's first left or right, then up or down. So it says label the x-axis. So x goes across, so this is my x. The y goes high. And remember, draw a C in the center to remember which is which. Follow the letter C and number 1, 2, 3, IV. Next one. Plot and label the following points on the coordinate grid. First, left or right. So my first number tells me to go left or right. So 1, 3, 4, 5, and then -4. So over 5, down 4. 1, 2, 3, 4. So I need to put a point here, and I need to label that A. Next one, -9, 4. First left or right. So -9 says go to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 4, it's +4. So 1, 2, 3, 4. So B. Okay, C is at -1, 0. So that's on the x-axis. So that's C, etc. So you have to plot all those points. The next one, oh wait, I've got to do this next one. So 1, 2, 3, 4, 5, 0. So that's D. So the next one says, what is the distance between point A and point D? So when I count distances on the graph, I have to count from one point to the next. That's 1, 2, 3, 4. So the distance from A to D is 4, and you have to do that with all of them. Okay, next one. Grouping symbols inside out, then exponents. Multiply or divide left to right, and add or subtract left to right. So I'm going to start with my grouping symbols. So remember that your grouping symbols are parentheses, braces, brackets, and the fraction bar. So I'm going to do what's in the numerator first. And when you have a compound expression up here in the numerator, you do that in order of operations. So exponents are first. So I'm going to begin here. So 3 to the second power, that means 3 times 3. So 3 times 3 is 9, and then I add 6. So I've got 9 plus 6 divided by 5. So this whole expression right here is equal to 3. And I write everything else down. So lots of people right now are tempted just to add 3 plus 10 and then divide by 2, but that's not what you have to do. So you have to look. So grouping symbols, nope. Exponents, nope. Multiply or divide from left to right. So I'm going to begin here. Do this math, and do this math, and then finally, whatever answer I get, I need to do with that. Order from greatest to least. All right, so greatest to least. The first thing I've got to do is I've got to look at these fractions. So I've got 2/3, 1/5, 3/4, and 1/2. All of these numbers can divide into 60, so I'm going to make a common denominator. There might be a number that's lower, but 60 just came into my head. Okay, so this one's easy. That's 30. All right, so 5 times 12 is 60, so 1 times 12, that's 12. And 3 times 20, that's 60. 2 times 20, that would be 40. And 4 times, think about the clock, 15, that's 60. So 3 times 15, that's 45. So these are my equivalent fractions. When you're going to organize things like this, we need to think about the equivalent fractions. But first I need to look greatest to least. So the greatest fraction here, I'm going to start with 3/4 because the fractional equivalent of 3/4 is 45/60. My next one is going to be 2/3 because that's 40. So I'm counting down and I just look at my numerators. Once I've got a common denominator, I'm just looking at my numerators. So you'll need to finish that one up. Okay, next one. Remember, coordinate grid. X goes across, Y goes high. City of Charlotte is extending the greenway downtown. They are starting at 0.43. So I'm going to start here. 1, 2, 3, 4. 1, 2, 3. So this is where they're beginning their greenway. And they want to stretch it 5 units south. So it's going to go 1, 2, 3, 4, 5. So you need to figure out what the address or the coordinates of that point is right there. I'm going to use the same graph here. And it says that Crestdale is located at -3, -5. So 1, 2, 3, 1, 2, 3, 4, 5. So there's Crestdale. And I live at -3, 2. So 1, 2, 3, 1, 2. The question is, how far apart are these 2 points? So remember, you're counting your loops like that, and you want to figure out how far apart they are. Next one, compare using less than, greater than, or equal to. Remember, left is less, right is greater. So if I look here, -6, -5, -6 is to the left, or it's less, so I draw 1 dot, 2 dots, and then figure that out like that. The tricky doodad on this one is the third one, and it says we've got this symbol here, and remember that this means absolute value, and absolute value, as you'll recall, is the distance from 0, and distance is always, okay? All right, and then the last one. Thomas is at soccer practice. His coach is having his team run sprints, so he runs from 2, 1, 2, -5, 1, 2, 3, 4, 5, to 2, 6, 1, 2, 2, 4, 6. So how far did he run? Well, he ran 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But then he said, so he ran from 2, 5 to 2, 6, and then he ran back again. So what's the total distance?